Hi, Algebra 2 students. Please turn to page 19 in your packets. We're going to take a look at how we can figure out how to calculate the area in non-right triangles. So if we take a look at number 1, we are told that we're dealing with a triangle that has lengths of 3, 4, and 5 centimeters. Now, we might recognize this right off the bat as a right triangle because 3 squared plus 4 squared equals 5 squared. So 9 plus 16 equals 25, and 25 is equal to 25, so I know that this is a right triangle. I know that my longest side has to be my hypotenuse, and I know that the legs are 3 and 4, however I want to put those in there. And I know since it's a right triangle, I know that these are connected by a right angle. Back in elementary school, or back in middle school, you learn about how the area of a triangle is equal to 1/2 base times height, or how area is equal to base times height divided by 2. They mean the same thing. So to calculate the area of this triangle, I'm going to take 1/2 times 3 times 4, which gives me 6, and I'm dealing with square centimeters. Okay, so this is lovely if we have right triangles, but not all of the triangles that we encounter are going to be right triangles. All right, so if you're interested in taking a look here, I'm going to talk about where today's formula comes from for finding the area of a triangle. I'm going to take a look at angle A here, and I'm going to label that guy as theta. Down at the bottom here, it's saying, hey, find the sine of A. And I know sine is equal to the opposite over hypotenuse. Compared to that theta, my opposite is h, and my hypotenuse is c, so I can write my ratio of opposite over hypotenuse as h over c. If the sine of A is equal to h over c, I could then clean this up a little bit by multiplying both sides by c, get rid of that fraction there, and now I know that c times the sine of A is equal to h. All right, it's so much fun, I could do it again. Okay, this time through, I want to take a look at c. I'm going to label that c with alpha. So compared to that alpha, h is still my opposite, and now this time through, a is my hypotenuse. So I'm asked to figure out the sine of c, which is still my opposite over hypotenuse, which is going to be h over a. So now if I clean it up a little bit, if the sine of c is equal to h over a, I can get rid of that fraction by multiplying both sides by a, and now I know that the a times c is equal to h. Okay, and h is that height. Now if we think about 1/2 base times height, in either one of these cases, I can replace my height with, my height is all this guy. So my height is c times the sine of a. So one formula is 1/2 b times c times the sine of a. Or I can take, I know my height is a times the sine of c, and there we go. So basically what we are dealing with here, if I want to find if I want to find the area of a triangle using this law of sines formula, or the sines formula, I need to know B and C and that included angle A. So I'm looking for SAS in order to use this formula. I need to know the included angle and 2 of the surrounding sides. All right, so if we take a look here, cruising on to number 3. So taking a look at that picnic table thing that we dealt with last time, it's telling us that, hey, Sydney's corner, we did this the other day. We're not going to recalculate it, but we used the law of cosines to figure out that the Sydney's angle was 83.942 degrees. If we want to find the area of this tabletop, okay, we're going to again deal with SAS. Well, this is the one angle that we know. The 2 surrounding sides are these. So if I'm dealing with 1/2, okay, I want my surrounding sides. So in this case, I could have 1 time A times T times the sine of big S. Okay, so my 2 surrounding sides. So 1/2 times 5 times 9 times the sine of 38.9 0.42 degrees. And we end up with about 14 square feet for that area. Okay. Now, in this particular case, we had already figured out that angle in our last class using law of cosines, but there is an easier way. We have this other formula called Heron's formula, and Heron's formula is a way to find the area of a triangle, and we use this when we have S, 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 so we have all three side lengths. And Heron's formula says, says we're going to take the square root. We got S times S minus A times S minus B times S minus C. And S is this weird thing which is called the semi-perimeter. And the semi-perimeter is, we're going to take half of the lengths of all three sides. Okay, so taking a look at this table again, we have side lengths of 6, 5, and 9 feet. So alternatively, we could...
Did you see where she did somebody come and get her?
Miss Ellie did. So if we take a look, the side lengths are 5, 6, and 9, so we can add all those up and divide by 2. And this is going to give us our semi-perimeter. Okay, so 6 plus 9 plus 5 is going to be 20. We divide it by 2, so our semi-perimeter is 10. So if we figure this out, we're going to plug in 10 for all places where we see S. A, B, and C are the three different side lengths. We have one side that's 5, we have one side that's 6, we have one side that's 9. I'm going to type all of this junk into my calculator, and yet again, I get about 14 square feet. All right, so that is going through and taking a look at how we can find area. What I would like you to do on your own, please take a look at number 6. This is your homework. We're going to do number 6. Here it's asking us to find the area of the quadrilateral. Which quadrilateral? You might choose to chop this up a little bit. So you might choose to break this up into two different triangles like this and find the area of each and add them together. You might choose to break up a triangle like this, find the area of each and add them together. Splitting it this way makes it a little bit trickier, so you can check that out. I also want you to take a look at number 7. Okay, taking a look at both of those. And then your job with the rest of the class time that we have today is to finish up Agile Mind. We are going to do all of the guided practice. Okay, so at this point we got 1 through 11, and then we're also going to finish up our more practice. You should have already done 1 through 7, so now we're going to finish this up with 8 through 10. All right, good luck, and let me know if you have any questions. See you next time.